Ready. Ready. Ready.
Hello, welcome to Enlightning. I'm here with Pete Wall. Hi, Pete.
Hello.
Hello. Will you introduce yourself, please?
Yeah, hi, my name is Pete Wall. I am a software engineer at Grafana Labs, and I've been doing all things Kubernetes monitoring for a while now. So I'm just super excited to be here.
All things Kubernetes monitoring. That is wonderful. So those of you who watch regularly, you know we've been learning a lot about observability lately. And so I'm super psyched to know about Kubernetes monitoring. One thing, like last week, we talked about micrometers. So we talked about instrumenting an application specifically.
Yeah.
And now I'm interested to get onto the infrastructure. Like, what do we need to do infrastructure-wise to set up observability?
Yeah,
so,
totally. It's a really important thing. You got to make sure, just as much as you want to make sure that your apps are running well, you want to make sure that the platform where you're running those apps are running well too. So yeah, very important.
And I don't expect an answer to this, but I'm also kind of interested in how it puzzle pieces together. Like if you're instrumenting this part of the application, is it also necessary to do it infrastructure? Like, is it either or? When is it either or, and when is it both or neither?
Yeah. Well, yeah. I think that, maybe as we kind of build up some of the concepts here, I can highlight where some of the things kind of blur the lines between infrastructure and application, because, ultimately they do kind of tie themselves together. So yeah, definitely I'll highlight those as we go.
Cool. Those of us who are watching live, please do say hi. And I'm going to remove our names so that we have more room on the board. And then let's get started. So what I'd like to do to start, Pete, is I would like to talk about why do we need Kubernetes monitoring at all? Like, what problem are we solving?
Right. No, that's a really great question. I think that when you talk about Kubernetes monitoring and why do we need it, what are we trying to solve? It really hinges a lot on the same questions that we ask when we're talking about monitoring or observability in general, right? Why is it important? It's what you want with observability. And, if I can take just a few moments to kind of talk about high level, like you said, we've been doing a lot of observability topics on Enlightning recently. But I think it's always useful to kind of level set, just to understand like the common terms, right? Observability is really just about understanding what's happening inside of a system. And why do you want to do that? It's so that you can better solve problems, take actions to fix or improve things. It could be more than just solving problems. It could be, I want to understand how things are performing so I can find bottlenecks, so I can find places to make improvements. The why is it important? It helps us catch issues before other people do. It's one of the things I like to say. I remember, back earlier in my career, back in the old days, the only way you knew that the system was down is you hear the shouting down the hall. And you're like, oh, should you load the website and see if it's still up and running or not? And, also back in the old days, debugging a customer issue, I'd get onto a customer escalation and you'd say, hey, can I get some logs? And you get like a tarball of like 2 gigabytes of just files. And you'd have to search and replace through like the text editors and stuff like that. And that's how you looked through logs and stuff like that. And so thankfully we've come a long way since then. So, what proper observability does is it builds confidence for us into the software that we deploy. And so infrastructure observability is about building confidence in the platform and where our apps are living. Obviously the application observability or the application instrumentation helps us understand what's going on inside of our apps so that we have confidence that they're performing well, that we can fix problems as we find them. And that, we're ready to build on top of that, especially when you talk about infrastructure observability. You want to know, do I have the capacity to add more? Or on the flip side, am I running, too much and I maybe need to start splitting things up? So, that's kind of where we go from that. Again, kind of talking about a little bit of overview of observability, it's useful to highlight the common data types that we see with observability.
I love this. Yes,
yeah.
please.
A lot of people say it's 3, but it's actually 4. There's a 4th one that's kind of up and coming and building more momentum.
Okay.
So logs. I mentioned logs. Everyone knows about logs.
Okay.
Everybody makes logs. In fact, what is everybody's first program when you're learning a new language? It's print hello world, right? So really, everybody's first program is printing a log statement, and then we just build on from there. So logging is the very basic thing that everyone starts with. Logging obviously gets more complicated from there. We can log to files, we can log to services. There can be structured logs or unstructured logs. So structured logging really just means that there's more embedded data in the logs rather than just kind of free flow text. But that helps later on if you want to do some analysis or some reading of those logs by a machine to pick out specific details, right? The next data type that people talk about are metrics. So where a log is recording kind of an event in time, metrics are more about a measurement of a certain thing that you're interested in. So metrics could be looking at how many requests came to a certain service or how many database connections you have open. Metrics are less about an individual event in time, but kind of counting things or measuring things over time. Kind of an analogy that I like to keep in my head. If I'm driving, if I'm driving to my kid's school or something like that, a log would be something like Pete got into the car, Pete put on his seatbelt, Pete turned on the car, Pete put the car into drive. Where the metrics would be more like, here's the speedometer. It's the measurement of the speed over time. Here's the odometer. That's a measurement that's always going up. Things like that. So they can capture 2 snapshots, but they're coming at the same question from different sides. What happened now versus, give me something I can quickly look at and understand.
I like this. I like your driving analogy. That really drives it home.
There you go. Yeah.
But also, one thing, when you said common data types and observability, logging, metrics, and traces have come up over and over and over again. This I'm familiar with. But what made me feel like this might be, when you say data types, what do you mean? I think logging are text. Well, you just said structured versus unstructured. So as simple as a text entry, or maybe structured where it has more data attached to it.
Yeah.
What does an actual metric look like? Also, a quick hello to buddies who are watching. Robbie's here today. Hello.
Hi, Robbie.
And Donna Tuck. Hello. I hope it's going to be fun too.
Yeah. So data types, that's a really great question. So the data type behind logging, as you said, it's mostly just text, right? It can be annotated text. It can be JSON. It can be, something more like that, but it's really just text. For metrics, the key things that come in from metrics, there's 3 components for a metric. There's the timestamp, when did we take this measurement? There's the actual value. So in my driving analogy, it's 30 miles per hour is the value. It's 30, and the metric, the timestamp would be, when we measured that. And then there's going to be labels attached to that. So the question, car equals Pete's car. It's things that
Mm-hmm.
differentiate that metric from other metrics that we're capturing. So if instead it's just me, but maybe I'm, I don't know, a car company, a car fleet company, and I want to capture information about every car in my fleet, I would get similar metrics. The car speed metric would show me all of the speeds from everything else, but I would use those labels to differentiate, okay, which one is coming from this car and which one's coming from this one. So that's the kind of underlying data type for metrics.
Okay.
Yeah.
And so there are 3 data types, and they're wrapped into one unit, or they're just 3 data types, and that's
3,
they're
but
correlated later.
They kind of all interlink with each other too.
Yeah.
You mentioned traces. Traces obviously then is the next one that we always talk about. Traces is tracking an event through different locations or different services and across multiple services often. And so that helps you really see how information travels or how a request travels through multiple locations, right? If I may keep leaning on my driving analogy, a trace may go to something like, I went from my house to the school, from the school to the grocery store, from the grocery store back to my house, or something like that. You see kind of a pattern of things. It's tracking that individual thing, but it goes deeper than logs in that it's not just one snapshot, but it's a collection of all of these snapshots, captured into one trace.
Okay, and then what's the data type?
The data type, what? I'll be honest with you, I'm less familiar with how that one works, and there's a reason for that. Like I said at the top of the show, I am all things Kubernetes monitoring. Once we start talking about traces, and then the fourth type that I'll talk about in a second here, those really start to lead more into the application observability, which is less my domain, but definitely, I'll talk about inside of Kubernetes where we will find those sorts of things too. So the fourth one, the fourth one that a lot of people don't talk about is profiles. So profiles is now called like the fourth data type of observability, and it's just right now it's in the process of being added to tools like OpenTelemetry or SDKs like OpenTelemetry, native handling of profiles. And what profiles are is it's very similar to traces in which it's tracking information through the service like profiles or like traces are, but instead of tracking an individual execution, this happened, then this happened, then this happened, it's more about gathering trends about what's going on through those different services. So the trace example that I gave, I went from my house to the school, to the grocery store, to home. What a profile would be is, hey, you've done that trip 100 times. You've gone from your home to school to the grocery store to home. And as we've been building up the records of all of those things, we've noticed that the trip from school to grocery store is always super long. There's like a red light there or something like that. So we've used that information to analyze to say, if you take a slightly different route, you could save 10 minutes on your drive or something like that. So
would a profile also be all of the parents in this area all have a trip, and they would that be considered a profile, or is that more of a metric? Like, is a profile important that the subject is always the same?
If the subject is always the same, you really start to narrow down on the specifics of that path. But generalizing the subjects means you can still you capture more data faster. It just might be a little bit more generalized, right? Yeah, definitely though. Like if you think about, sometimes you open up Google Maps as you're driving or something like that, and it says, this stretch of road is going to be longer than the rest of them. It's because we have so many cars that are also driving slowly. It can kind of figure that out. So with profiles, the more data that you're gathering, the more information you can get. But if it's less specific, if it's less about an individual, like just my trip, it might kind of smooth the lines over if you're looking. In practice, kind of stepping aside from the analogy a little bit. In practice, you are measuring the performance inside of your web service of a specific service call. Somebody clicks this button you want to see what happens internally. You are looking at the same call, but it's over 1,000 or so different invocations of that. And the real thing that you're trying to look for there is, hey, this specific function is always really slow. Where can I spend some of my time engineering to improve the performance here?
So if like traces are maybe a series of connected logs, is that across different locations?
Yeah.
A profile be considered a series of connected metrics?
I love that you made that connection, because that's really, when I was learning about these, that's what turned the light bulb on for me too. It's like logging is about logging individual events, and traces is a path of individual events. Metrics is a measurement at a specific time, and profiles really does feel like it's a path of measurements over a specific time. So yeah, totally.
Cool. Awesome. I've never heard of profiles before, and it's a joy to have some information I'm very familiar with kind of turned on its ear a little bit.
Yeah. So, all right, at this point, I think it's good to start talking about Kubernetes. Why do we care about all of this in Kubernetes? Where do we find these sorts of things inside of Kubernetes? Like I said at the top, Kubernetes is a platform where we run these apps. And so it's important for us to understand how that platform is working, if there's any things that we need to be concerned about, and are we feeling confident that it's stable enough to take on the apps that we want to deploy if it's ready for more. So I think there's really 3 questions that we are trying to ask. The first one is stability. Is the system stable? Is it healthy? We look at things like looking for issues in the control plane.
Before we jump into this level, even though it's still kind of high level, can we just can we just say what is monitoring in Kubernetes?
Yeah, right.
And then ask the questions. Yeah.
No, that's great. Yeah, monitoring Kubernetes. The kind of first glance at that would just be understanding the state of your Kubernetes clusters, right?
Okay.
Beyond that, it's about making sure that you're using your cluster in the best way. So most efficiently, being able to optimize for, whatever is important for you or your organization.
Is understanding. What is happening in your cluster, or across clusters, or is it a single cluster?
It mostly focuses on one cluster, but there are definitely places where looking cross-cluster is important. For example, if your organization is running in a multi-cloud environment or something like that, you've got clusters over, on this cloud, you've got clusters on this cloud. Being able to put them side by side and understand, how they're performing differently, how they compare to each other, that can give you a lot of information as far as where do you want to invest more, and it could be things that you're asking, like cost. Are the clusters that I'm running over in this cloud costing more for basically the same thing, or energy usage? That there you can even measure. Am I running my cluster efficiently when it comes to the power consumption that it's using, and where that power is coming from? So cross-cluster gives you that kind of insight to see comparisons between those things, and can even give you insight into how do you build as your organization grows, or how do you downscale if it's time to deprecate a service or something like that.
So did I capture this right? Monitoring Kubernetes is understanding what's happening in a Kubernetes cluster, with the idea, if you can understand the performance, you can improve the performance.
Yep. I think that captures it great. Yeah.
Okay.
Because it's beyond just, observability for the sake of bug fixing or finding issues. It's about optimization. It's about how do you make sure that things are running as best as they can, as efficiently as they can. And the cluster is important, but the apps that are running on the cluster is, the reason why we have clusters to begin with.
The goal is optimization.
Yeah.
How often is that goal achieved? Optimization is a big word. It sounds like perfect, which is
That's
impossible.
Right. We always just try to point ourselves in the direction of that and improve where we can.
Hello, Deb. It's good to see you again. Deb asked a question practical. Will you be more specific with your question, please? I don't think I understand. But thank you for asking a question and thank you for being here.
Where I will riff on that, talking about, if the goal is optimization, if the goal is perfect, what are practical things that we can achieve from that? What are some things that we can do today that actually get us closer to that? Obviously the bug fixing things, if you are monitoring your cluster and you're finding the logs, you're finding issues, and I'll talk about kind of the where, logs, metrics, traces, profiles, where they come from in Kubernetes in just a second here. But if you're monitoring those things, if you find those things, the sooner that you can find the errors, the sooner you can report those errors back to the devs, the sooner that they can put in fixes that, improve the performance of the apps. Perhaps it's the more that you're monitoring things like the requests and the limits of the apps that are running in your cluster, the more you can, right size things so that you are making the most of the space that you have in your cluster. So practical in that, there are, the more insight that you get, the more that you can find places to just kind of like really best fit the things that are going on. Yeah.
We got another question. Optimization depends on traffic. So if traffic, if you're optimizing for a certain amount of traffic and that amount of traffic changes, you're not optimized anymore, I think.
Yeah.
So can it really be automated if the traffic changes? What the definition of optimization?
Right. No, and that's a really great point. No service that we deploy out to the public, no service even internally, none of them stays static. Ideally, you work hard on a service, you deploy it, you open up the ingress, and so you tell all your friends, hey, go to whatever.com, and you can see the thing that I made, and it gets really exciting. Then it takes off, and then now suddenly thousands of people are going to it, hundreds of thousands of people are going to it. There are different needs that take place when that sort of event happens. So, and or if you're talking about a storefront and you've got a Black Friday, you're going to get a huge spike of traffic and then it's going to calm down. So optimization in the form of that, totally. Yeah. That's where observability shows where the spikes happen, but also shows where things kind of calm down and you can make changes. There are tools within Kubernetes, and maybe we should start talking, about building a Kubernetes cluster on the board in a second here, but there are tools within Kubernetes that can help you do that. I'm thinking about horizontal pod autoscalers or, other tools where they can react to changes in demand, in traffic, and give feedback or actually try to right size your apps. But you also want to make sure that those things are configured well so that it's resulting in an app deployment that's right.
So to help me close the loop on what's happening on the board right now, will you throw a couple more things at me for what monitoring Kubernetes is helpful for?
Yeah. So we talked a little bit about
fixing, right sizing. Yeah,
we talked about, so with right sizing, and I like to just call it more like efficiency, right? Because the question behind efficiency is, am I using my cluster well? And there's really kind of two scenarios that we're trying to avoid. The first scenario is, I don't want to use a cluster. I don't want to be paying for a cluster that's sitting mostly idle. It's 99% doing nothing. It's 1% running a single app. But for whatever reason, I allocated a cluster that's hugely over allocated for what I'm going to put onto it. Maybe that's okay if there's plans for more things to come on there. Maybe it's not. Maybe it's just a matter of like, I didn't know which to choose when I was picking my node types, and so I just picked the big one because that's going to fit. So that's one thing. That's not necessarily a problem, but there's waste that's happening there. The other scenario that we want to avoid is the complete opposite end. We've got a cluster that's extremely full. It's allocated with X amount of CPU and memory, and with all of the apps that we've deployed on there, we are nearly maxing out those limits to the point where if we put one more on there, we're going to start having problems. Pods aren't going to be able to start. Resources are going to start getting dropped. We might get things that are getting throttled, and that's definitely going to affect the user experience. And so we want to know where we're reaching those limits before we hit those limits. So that's where the efficiency question comes in. There's some kind of side questions that we ask about that too. I mentioned cost. Given the type of cluster that I've allocated, how much am I spending on that? And am I okay with spending the money for a cluster that's sitting idle, but it's ready for me to deploy more stuff when I need it? The energy question, if I know that I'm running in a data center and it's getting its power from the wind, or it's getting its power from coal, am I okay with it sitting mostly idle, spinning fans and churning up electricity, when maybe I could move that cluster to a different place, or make the cluster smaller, and so I can optimize for an energy concern too.
So efficiency is one or all of these things, or especially, and it's also unique to your particular use case and your goals for what you want.
Right. Back in the day, before Kubernetes clusters, before virtual machines and all those sort of things, when we would buy equipment to start up to put a new service into effect, you'd talk to the IT procurement team or something like that, and hey, go buy me a server, and they would typically 3x, 4x what you asked for, because everything is going to get a little bit busier over time. And in today's world, where it's as easy as a couple clicks to figure out what you need, it's as easy as a couple more clicks to change it later on. Why not make sure that you're using things just as you need them? So
I think of the early days of the internet, when like a retail store, Toys R Us, I don't even know if Toys R Us exists anymore, but for like Black Friday, they would have to have all of the machines needed for their highest amounts, even though it mostly sat empty. I don't know if literally Toys R Us did that, but like that's the idea. Before shared compute, before the cloud, everyone had their own data centers, and it was normal for it to sit empty.
I think
just to be ready for that peak.
Yeah, definitely. I mean, there was a lot of ideas of like, okay, we know things are going to be ramping up, and so we are going to start turning on data centers that we've had sitting idle for a while, and doing that sort of thing. I think that, obviously, as all things have kind of progressed, as software as a service, as web, just internet shopping has become more and more popular. That's where we also have the, more and more popular of just being able to offload from on-site data centers into the cloud and things like that. So thankfully, they've kind of come hand in hand. But yeah, no, definitely that was a thing. You just had to over provision and hope that you did it well enough. Because at that point, it was worse to have underpaid, but then had failures, than it was to overpay and then, you're ready for the future. So.
And it's like a calculation that each business is going to make separately, depending on their particular what they're delivering.
All right. So I want to start talking about how do things go as far as like logs, metrics, traces, profiles. Where do they come from within a Kubernetes cluster? Especially the infrastructure stuff, but also a little bit into the application stuff too. So I think what might be helpful, if you want to draw like a simple three boxes, we'll do a little 3-node cluster, and they can be. It doesn't have to be big. So
like what down here, small?
Yeah, that'll work.
Okay. We have a 3-node cluster.
One node will be our control plane, and then the other two will be our workers.
Okay.
So Logs. Where do the logs come from? The logs, the first thing that people think about when they think about logs on Kubernetes are the pod logs. Like I said at the beginning, the first app that we all write is Hello World. And so if you create a container that just outputs Hello World and then throw that onto Kubernetes, that's going to show up as a pod log. So Kubernetes captures anything that's emitted as standard out or standard error as a log from that container. So it makes it really easy. You really don't, as an app developer, you really don't have to do much as far as, setting up like a log ecosystem. You just have to print your information. Less people know. So how do you find that? Typically you use like the kubectl logs command, and that will actually find the logs that are printed. Less people know where those logs are typically actually live. If you're running a thing on your terminal and you output standard out, it lives as long as that terminal is showing, but as soon as you close your terminal, it's gone. It disappears, right? But how Kubernetes does it is anything that is output as standard out or standard error, as I said, that will actually record it onto each of the individual nodes. So there's a special directory on the node itself where it stores all of this output as files. So
it doesn't matter if it's a worker or the control. It's going to have its own directory that has logs in it.
Yep, exactly.
That's my terrible file system.
No, those are great. Yeah. So any node, if you're running a pod on there, the pod logs will be captured as files on the node. And that's really helpful because if you have a pod that crashes or something that restarts, it will have the logs for that pod after it's gone. And so you can do a little bit of forensics and find out what was happening there. You don't have to worry so much about how old the log is. You can always get to that.
Fascinating.
The other logs that we capture, or that are interesting for us when we talk about Kubernetes monitoring, I just call it node logs. Just logs that aren't captured by pods, but they are captured by the running components of Kubernetes. And typically where you would see this happen is like, the kubelet itself. The kubelet lives on every node and it kind of manages what happens on that node. The kubelet is not itself a pod. And so where it logs, if you're running a cluster that's, like a standard kubeadm setup cluster, the kubelet will write to, it's like journal D logs or something like that. It's not necessarily important where it's writing, but the kubelet will have its own logs that will be separate from those pod logs. Those would be really helpful for us to look at later if there's any like actual like infrastructure issues with the cluster turning on pods or things like that. So those would be more pods that we would want to capture.
So kubelet.
Yeah.
Say that again real quick.
You're good. Yeah. The kubelet is a process that runs on every node.
Yes.
And so it's managing what's happening on that node.
Yeah.
Works with the API server. API server tells you I want to start up stuff there. So the kubelet itself will log about how things are going for itself. But those will be in a separate directory. Those will be in a separate location on the node itself.
So pod logs are stored in directly on the host machine, and also kubelet logs are in a separate directory.
A separate place.
Each on a host machine too.
Yep.
Cool. Let me acknowledge a couple comments. Epic Tralala's here. Hello, friends. Good to see you again. And Romola was wondering where we can get a recording to watch later. I'm not sure about the LinkedIn interface, whether it saves the recording, but it'll definitely be on YouTube. So you can go to the VMware Tanzu YouTube, or you can go to my YouTube, which is Wiggity Whitney. Very quickly, I'll put our names on here, and then you can see. Yeah. Excellent. Okay, sorry to take a detour.
No, that's absolutely fine.
Okay, so great.
Yeah.
I'm not
So
sure.
pod logs, kubelet
Okay.
logs, or other,
Yeah.
node logs, things that aren't, running as a pod on the system, but they're still creating logs. We'd want to make sure to get those. There's a third kind of logs that are interesting to look at too, and we call them cluster events.
Mm-hmm.
So a cluster event is, most people will see them if you do like a kubectl describe on your deployment or on your pod or something like that. There'll be a list of events at the bottom, and it's things like, pulling an image and started the pod, and all of those things that log what the life cycle, the stage of that pod or that deployment or something like that. Those are also really, important and information for us to get. And so those ones we pull straight from the API server. So rather than trying to read them from a file, we just ask the API server, hey, tell us when things happen. We want to know, as this pod is starting, let us know what the status is of that.
So the API server is getting them from etcd, probably?
Yeah. So the API server, as you deploy things, you're telling the API server what you want to do. The API server kind of is the interface for a lot of Kubernetes, right? It will record into etcd, here's the state of the system that I've been told I want to keep online. It will work with the kubelets to make sure that, those pods are actually being brought up and deployed and things like that. The events of those pods, those workloads, we access them through the API server, but the actual record of them, I have to check. I think they would be stored, or at least it would work with etcd as far as the storage for that. We do have a question. What is the link between? Yeah, maybe you hit the button. What is the link between the kubelet and the API server and protobuf? So
what is protobuf? I don't know.
Protobuf is it's a communication protocol. It's a way of kind of sending communication details back and forth. This seems like kind of more of a generalized Kubernetes question. Obviously, the kubelet and the API server, they talk back and forth with each other a lot, as far as managing what's actually deployed onto the Kubernetes cluster itself. And you can't have one without the other. The API server kind of runs the show, but the kubelet is, the individual pieces that are actually doing the work, right? So, and protobuf, this gets a little bit deeper than my knowledge level, but I believe they're using the protobuf communication to kind of coordinate and talk back and forth. But yeah, I wanted to highlight that.
So to recap, where do we get logs in Kubernetes? There are 3 types of logs. They're pod logs, and those are stored in directories on each node in the cluster, regardless of whether it's a control plane node or a worker node.
Yep.
We have the kubelet level or node level logs, and those are also stored in different directories and also stored on each node, regardless of whether it's control plane or worker node.
Yep.
And then the third type of logs we have are cluster logs. And those are accessed. You can see them. They're accessed via the API server. And they, when you see an event attached to a certain object, that's the type of logs we're talking about.
Yeah. And
cluster
so events is what I call them. Rather than cluster logs, just kind of cluster events. But yeah.
Okay. And they are accessed via the API server and probably stored in etcd.
yeah, they're stored, but with the API server is the best way to get them. So.
Okay.
Yeah. So that's where logs are. Obviously, depending on how the cluster is set up, the node logs may be in a different place. Maybe it's something that you'd have to ask from your cloud provider. But typically the pod logs, they stay in the same place. The cluster events, we still get them from the same place. It's a pretty reliable place to get them. Maybe the asterisk on this is that a lot of times you'll have an application that's writing to a separate log file. Like if you have an app that was written kind of in before the Kubernetes or the containerized days, and it always logs to server.log or something like that, and not standard out, standard error. There's other ways to get those logs. We'd be talking about like sidecars or other kind of approaches. I'm going to try to, not necessarily get those at this point, because that would be a special handling for those individual applications. But that's definitely something to call out, that applications will also log to different places. And we want to be able to discover those and then, capture them as well, bring them all holistically into kind of our centralized, log location.
I have a question.
Go for it.
I've done an episode on FluentD and FluentBit.
Yep.
So so if I'm using FluentBit, is FluentBit or FluentD getting the logs from these places that you talked about? And then or it runs as a daemon set. How does FluentBit and FluentD relate to this?
Yeah. So that's a great question, and I think that's useful to talk about how would we actually capture these things in real world, right? So capturing these logs, like we kind of alluded to, the cluster events we get from the API server. We just ask it, hey, send us the cluster events as they come in. The pod logs, the ones that are stored on the nodes. It is setting up a daemon set. You want to deploy something, some sort of collector, and that could be FluentBit, or that could be a number of other technologies, OpenTelemetry collector, Grafana Alloy. There's a number of different options there. You set it up as a daemon set, and it will, when you deploy it, you give it permission to read those file paths. You tell you deploy it with the volume, host path volume mount that says, I want to be able to read var log pods, typically is where it is. And then it actually will see those files and then capture that. You can also, a common thing when you got those application logs where they're writing to their own private file, a common thing you'll see there is to deploy it as a sidecar to those apps. And so it can access the same file that's being written and also read those logs. So, but the daemon set approach is kind of the best way to do it. You can, with that same daemon set, if you don't need the sidecar, with that same daemon set, you can get the cluster events, you can get the pod logs, you could get the node logs too. So that's the common way to deploy some sort of log collector. Yeah.
Okay. It's all three types of logs. And then, so a sidecar is another possible way.
Yeah.
We won't. Okay. And then,
the sidecar approach works great. The why you would maybe use a sidecar over the daemon set is the sidecar can still capture the standard out and standard error. And so rather than reading from the file on the node, you can just get it straight from the source. Sidecar approach could get those separate application logs. You lose necessarily the ability for it to get the node logs, because those sidecars won't be configured to ask the node directly, give me your logs. And potentially, depending on how many pods you have, it may be larger footprint. You may be deploying more extra containers to get all this information, rather than if we have a 3-node cluster. So as a daemon set, I'm deploying 3 pods. But if I was doing a sidecar and I've got 100 deployments on there, I may be getting 100 extra containers. So it's a little bit of a trade-off which method you want to go for.
I have a question. Let me finish my thought. No node logs, possibly high overhead.
Yeah.
My question is, if there are lots of applications, lots of different workloads are running in the cluster, it's likely that different teams are in charge of different workloads and different teams want different logs.
Yep.
So how does a team get their particular logs out of?
Right.
How does multi-tenancy work?
Yeah. No, that's a great question. So with the daemon set approach, the team that's deploying the daemon set would be part of a monitoring team, platform team. And so with that, they would be saying, no matter what gets deployed with the daemon set, we're going to capture the logs for it. with the sidecar approach, that may lean then more towards the application developers to say, when you deploy, if you want to get logs for this particular thing, use this pattern or something like that.
So that could be a benefit of the sidecar way is multi-tenancy?
Multi-tenancy, it could give more customizability, maybe I'll say, to the individual app developers on how they want to get those logs captured. So flexibility, maybe we'll say.
Flexible. We have a question.
Does
having sidecars allow for faster logs?
That's a good question. In my experience, there hasn't been that much of a difference at all noticeable as far as the speed of capturing logs between using the sidecar pattern or using the daemon set pattern.
But the daemon set, I didn't leave enough room to do it justice. It's the more common one, right?
That's the one that I've seen more common, yeah.
Okay.
All right. Let's swing over and talk about metrics.
Okay.
Because the board is filling faster than I expected. This is good. It's so much great information. So when we talk about getting metrics from Kubernetes and the metrics that we want to get that help us understand how our cluster is performing and how things on the apps that are running on the cluster are performing, there are 3 different categories of metric sources that are built in to Kubernetes. The control plane itself has a whole bunch of metric sources. So the API server will tell you its own metrics. It'll be things about, request time and, responses from requests to the API server. So how is the API server? Is it able to keep up with all the requests that it's having? The controller manager, the scheduler, other control plane components will have their own metrics as far as, are they able to keep up with their job? And so they'll have different measurements there.
So 3 methods are built into Kubernetes. And so one is they're attached to different components.
Yeah, just control plane metrics is just kind of one category that I'm calling out there. So all of the control plane components, how are they performing? That's kind of one set.
Okay.
And these are the ones that are built into Kubernetes, right?
Okay.
The second one, the kubelet themselves, each kubelet will have its own set of metrics. And those kind of, part of it is talking about how is the kubelet performing, right? That's important. We want to know that. But it also is giving some interesting metrics about the work that the kubelet has done. So what pods are running on the cluster? The kubelet is responsible for starting these pods, for making sure that they're there and getting them up and running. And so the kubelet metrics will tell you about the state of the pods running on the cluster, the requests and allocations that they need, that sort of stuff.
So state of kubelet itself and state of pods that kubelet is running.
Yep.
So 2 different. Okay.
So it's about how am I doing, and then also how is the work that I'm doing, how is that performing?
Okay.
And then the third one is C Advisor. So capital C, capital A, C Advisor. C Advisor runs kind of parallel to the kubelet. So it's on every node of the cluster. C Advisor is a Google project that, the name kind of implies it comes from, it's an advisor for containers. So it's part of the container orchestration piece of it. And so the metrics that C Advisor gives you is all about all of the containers that are running because of the pods, because of what the kubelet has started up. It's container metrics. So the CPU usage of the container running in the cluster, the memory usage, the network traffic in and out of those containers. If we think of the kind of the lowest element of work that's going on inside of Kubernetes, it's always all the way down to the container level. And so C Advisor gives us a lot of information as far as, what is running actually in those containers. That's going to be really useful when we start thinking about, if the CPU usage of this container is super high, do we have enough capacity for it? If it's super low, are we over provisioned for it? So that's where we get some of that information.
So the control plane one, that's just about the state of the control plane.
Yeah.
And then as far as our workloads go, and then we have state of kubelet, which is more about at the cluster. And then as far as our workloads go, we have pods being captured as part of the kubelet metrics, and then container or granular container metrics being captured by cAdvisor.
Yeah.
And state of control plane. And then, so these are captured, but like when you talked about how logs are captured, you kind of talk about like where they live too.
Yeah.
Where do these live? Where do the metrics live?
That's a great question. So the way that those metrics exist, and then how do we capture them, right? All of these systems use kind of the Prometheus style of creating metrics, where internal to those, each of those programs, the kubelet or cAdvisor or the control plane components, they will maintain their own internal measurements, the metrics. They'll maintain just like a variable inside of themselves to say, for this container, we're talking about cAdvisor, container A running in namespace B has CPU level 50% or something like that. And then as things change, it will be measuring constantly. As things change, it updates its own set of variables. Then, like we have a daemon set that captures logs, we'll have another deployment of some sort of collector that will ask periodically, hey, cAdvisor, give me your set of metrics. And then so cAdvisor will just then dump everything that it knows about all of the measurements that it's been taken to the collector. And so it says, here's all of the CPU measurements for all of the cluster or the containers that I'm looking at. Here's all the memory measurements for all the containers I'm looking at. And the collector then will go to the kubelet and say, hey, kubelet, give me all the metrics that you have. And then we'll talk about, here's the pods that I know about. And here's the, my own internal health and that sort of thing.
So is it accurate to say each one of these stores metrics information in memory and then gives it to a collector?
Yep.
When asked.
Yep.
Okay.
Yeah, and it's typically a kind of a pull method. The collector will ask it, give me your set of metrics now, which has the benefit of you can kind of speed it up or slow it down. If you really care about granularity, you could ask it every 5 seconds if you wanted to. If you just care about, I just want to get a measurement every once in a while, then you could go, 10 minutes or something like that. The typical what we call a scrape interval is 60 seconds, 1 minute. So we typically ask these services, give me your set of metrics once a minute.
So,
and there's a trade-off there, obviously. The faster you ask for the metrics, the more information you're going to see. You're going to be able to see things as they change sooner and react to them quicker. You're going to have more data. It's a little more granular. The graphs are going to look nicer, but that's just more data that you're getting, and eventually it's more data that you're going to have to store somewhere. So trade-offs.
Yeah. How often? So I haven't learned much about metrics, but the thing I can infer, like a metric involves some sort of calculation, it seems like.
Yeah.
And so unlike logs, it's like a measurement once in time. So it's almost, logs to me are like pure storage almost, because there's no calculation involved. It's just documentation, move it on.
Right. Yeah.
So there's calculating involved with metrics. And so are these components just measuring something, or is it doing some calculation? Like where's the compute of the metrics happening?
Right. Yeah. Typically the services that are getting the measurements, that are keeping track of things, that are doing the measurement, they are doing very little compute on them. And sometimes it will do things like, we're going to convert Fahrenheit to Celsius or something like that. But for the most part, they're not trying to infer a lot of information.
Okay.
They're just capturing kind of the raw state of how things are.
Okay.
The collector process, which lives on your cluster, that will get all of this raw information. It could do some calculation there if you want to make kind of a meta metric out of some calculation. Typically, I don't see that. Where you do see that is that all of those metrics get shipped off to some metric storage. So it'd be like a Prometheus database or something like that. And then when you're visualizing it, when you're making the dashboards around that, when you're making the websites that show all of the information, if you need to do calculations there, that's where you would do it. You would write a query that says, give me all of the CPU, and then give like all of the CPUs that the containers are using. Give me the CPU capacity of my cluster, and then I can calculate how much of my percentage of the cluster is used in that sense. So it would be way more on the visualization end rather than on the collection side of things. Okay,
that makes sense.
Yeah.
And then this may be a remedial question because I don't know much about metrics, but is there like some sort of standard of, because it seems like a metric could be anything in the world that you want it to be, right?
Yeah.
Is there some sort of standardization in terms of what, like when we say metrics, what is what we can assume is collected unless said otherwise?
No, that's a great question. Yeah, no, totally. Metrics, there are so many different kinds of metrics. It's amazing. And I'll share a couple special add-ons that we almost always see inside of Kubernetes as far as like extra metric sources. And some of them get really fun. But in general, a metric is just some like a point in time. They're very time series based. So it's a point in time and some sort of numerical value. And so it is, at this point in time, my CPU usage was this. At this point in time, going back to the beginning of our chat, the driving analogy. At this point in time, my speed was this, and my odometer was this, and the number of passengers in my car was this. That sort of thing. You want it to be numerical because you want to be able to compare with earlier points in time for that. You want to see trends go up. You want to see trends go down. You want to have a gauge that shows, gas, amount of gas in my gas tank. That the numeric value of it gives you comparison. The time series value of it gives you the ability to see how things have changed over time. Does that answer your question?
Yes.
Okay.
So the answer is no. There's no standardization. But
yeah. There's so much that you can measure with that, and there's so many things that are add-ons that the community has developed. A few that I do want to highlight because these are ones that we typically see inside of a Kubernetes monitoring setup. The first one is one that's called Node Exporter. Node Exporter is kind of it's built with the inside of the Prometheus project, so it's highly tied to, or not tied to Prometheus, but it's part of the kind of the Prometheus community. But Node Exporter, that when you deploy that onto a Kubernetes cluster, its job is to measure the health of the actual nodes, so the physical computers running the nodes of your Kubernetes cluster. So much like cAdvisor is there to measure like CPU usage and memory and file system usage of the containers, Node Exporter is saying, how much CPU is available and how much is being used on the actual node. And so that really is useful for looking at capacity of the cluster, memory usage of the cluster, even like the file system level. We are, like I said, we're writing pod logs to files. You want to make sure that your disks aren't getting full. And so that's what Node Exporter is looking at.
So specifically CPU and memory of each node.
Just all health of the node. It's monitoring, kind of at the computer level. CPU is one of them, memory is one of them, file system is one of them. If you have a node with a GPU on it, we're seeing, with AI, we're seeing way more GPU workloads that are going on to Kubernetes. So it's the GPU usage of the workload of the node. So if, measuring how much that is being utilized within your cluster.
Okay. GPU examples. CPU.
Yeah.
Memory, disk space. Yeah.
Yeah. So that gets deployed as a daemon set onto the cluster. So if we want to get information about every node in the cluster, we need to have this piece installed on every node of the cluster. But that's how, and then the same collector that's getting the cAdvisor metrics, the kubelet metrics, it would also be asking Node Exporter, hey, tell us the metrics about the nodes. The next one that I wanna call out, because it's another exporter, another metric source that we see that's deployed almost on every cluster, is one called Kube State Metrics. So yeah, KUBE State Metrics.
Okay.
I just call it KSM because KSM is a lot more fun to say.
Is that just you, or is that a universal thing?
It's a universal thing. You see KSM in the docs and stuff like that.
Okay.
But Kube State Metrics is the official name for it. So Kube State Metrics, what its role is, it's kind of interesting. So there are some kind of true metrics that it makes, and a true metric meaning like a measurement of a thing. So it looks at all of the objects that are deployed on your cluster, the daemon sets, the deployments, the pods. It makes metrics out of how all of those things are related. So a good example would be, I made a deployment and I say I want that to have 3 replicas. So a metric that Kube State Metrics will make is to say how many replicas are running for a deployment. And so at the beginning, it will say, the metric will say 0. And then as pods come online, the metric will go 1, 2, 3. Another metric will be how many replicas did I want to have? What was the desired number of replicas for a deployment? And so that will always be 3 because I deployed it saying I want 3. And so these are less about measurements of like the CPU or some sort of underlying resource, but this is looking at what's deployed on the cluster as a whole and saying, what did we want? What's available? It's about tying the pods to the deployment. It's about tying those to the individual namespaces. And so this one is kind of an interesting one because what it lets us do after we've captured this is it almost lets us recreate the entire topology of what's deployed onto the cluster just by looking at the metrics.
Yeah, I mean, what I'm hearing from you is like, it sounds like actual state versus desired state, like the whole function of Kubernetes, like storing an etcd, but maybe it knows actual state and it knows desired state and it's attaching timestamps to when things are happening.
Exactly.
So therefore it's okay.
Yeah. And so like an example of why you would use this, aside from just knowing, am I running the desired state? Is the current state matching the desired state? But an example could be, do I see, in my 3 pod deployment, do I see it dipping to 2 and then back to 3 and then 2 and then back to 3, which might tell me like something's crashing, but it's, Kubernetes is fixing it. But but something's crashing, but it's never going to 0. So maybe you'll never, like the users will never complain because it's still working. But maybe I want to go investigate, why is there some instability here? So that's that measuring of the desired state versus the actual state over time will let you see those sorts of things.
Yeah, I like over time more than attaching timestamps. Over time. Cool. And then so can you help me think of a more succinct way to give that example of what it captures? Like I hear you about like a pod going from 2 to 3, 2 to 3, 2 to 3.
Yeah.
And like having
yeah, I mean it's about the state of the cluster without just restating the name of it. Kube State Metrics, right? It's metrics that gives you the state of the Kubernetes cluster. No, it's about seeing the state versus desired state. Oh, wait, but when we talk about an example, yeah.
Yeah. I got it.
Counting.
Okay.
Yeah. No, I think that's really good. There are two more that I want to call out here because these ones are fun too, and they use cases that we've talked about earlier today. There's a CNCF project called OpenCost, and OpenCost
Okay.
is cost metrics.
Uh-huh.
And so what it does is it actually looks at it understands the infrastructure that you're running on. So it can see, is this cluster running on AWS, or is this cluster running on GKE, or is it a bare metal cluster or something like that? And it can estimate what are the actual dollar costs for these workloads. Because it can know that there are published pricing tables for for a given node in AWS, and for the resources that are using there. And so it can say, this deployment that you're running, that's going to cost you, approximately, this much money to run a deployment. And if you scale that to 4 replicas rather than 3 replicas, there's a financial impact there. So that's obviously really useful to looking at, what's the bottom line dollar amounts? We talked about the example, back in the early days of you just have to go out, buy hardware, put it into a rack and start it up. It was easy to tie the financial implication there because there's an expense that you see. But nowadays you don't buy the hardware, but there's still a financial implication. So the more that we can tie what are we running, and then also with something like this in real time to getting metrics about what is the dollars and cents of running this, we can actually react to it faster.
That's pretty cool. We're living in the future. Yeah.
That's right. Another CNCF project that I'm really excited about, there's one called Kepler. And Kepler does similar to OpenCost, where OpenCost measures the dollars and cents of your workloads. Kepler measures the energy usage of your workloads. So it talks to the node and it can calculate, like almost at the watt level, what's the power on the CPU or the memory or the GPU that this workload is incurring. And so it can measure, just like, you have the light bulbs, and, the old light bulbs would be a, 40-watt light bulb, 60-watt light bulb, 100-watt light bulb. It can tell you, here's how many watts this workload is generating. And so then you can do things like, how do I optimize to lower my cost? Or, I've got a data center over here that's running all on wind power, and I've got a data center over here that's on coal and oil. I can move some workloads over there without having any problem. I might as well use a better resource for power in my clusters too.
So that would be the answer to optimization is more about having it run in a wind powered data center, or is it re-engineering the workload to use less energy, or both? It
informs you about both things, right? Because it could be, where can you move workloads to more energy efficient sources? But if you have, you're doing some sort of like a blue-green deployment, and you've got app version 1, and you can capture over time the energy usage of that, then you can say, hey, we re-engineered things, we refactored the algorithms or whatever, and we made it more efficient. We're going to deploy app version 2. You can start capturing the energy metrics of both of those apps running in parallel and say, yeah, no, there's a 30% drop of energy usage, not just like CPU or memory, but like literal energy usage of the second app. And so, yeah, this looks good. We're going to start rolling it out.
Okay. I don't think that one needs an example. It's
really cool. Yeah. And
it
so
is
those
super
ones,
cool.
those are also CNCF projects. And so it's really exciting to see, like, there's a lot of emphasis and energy coming behind those things. So, yeah.
I love it. And it'll take a couple of months perhaps, but I do intend to do Enlightning shows about both OpenCost and Kepler.
Awesome.
I'm excited. Yeah.
So I could go on and on and on about different places, different exporters, different metric sources and stuff like that. There's tons of them out there. They're actually pretty easy to create yourself. And so you can create your own exporter. You could create one that ties into your thermostat and gets, temperature and humidity and that sort of stuff.
Wow.
But these are the big ones that we see within Kubernetes monitoring, capturing kind of the state of your cluster and some of the workloads that are on the cluster. I promised I would talk about traces and profiles. Those ones start to push more into the application side of things.
Yeah. Before we get to that, there are a couple questions hanging.
Oh,
One
yeah.
One of them's not observability related, but maybe you know a quick answer about how to set up kubeconfigs, or a good resource for that. Probably the documentation of Kubernetes.
Yeah. So kubeconfigs in Kubernetes, it's going to depend a lot on how your Kubernetes cluster is set up. There's ways that you can ask it to create users and things like that, but I would say look at the documentation for the individual, like the way that you started your cluster.
I'm rooting for you. And then Ravi asked, what about using other processors like ARM instead of x86? Can the energy efficiency of using different processors be determined?
Yeah, absolutely. So actually the Kepler project themselves, they just released a new update. They've been able to capture energy stats from ARM processors. They just released a new one that supports the Graviton style of ARM processors, which is AWS's flavor of ARM. So yeah, it definitely has the ability of getting more than just x86. It can do both. So that's really exciting.
Ravi, I'm putting your information on the board as an example. You changed the board today. Efficient. Okay. How are you, Pete, feeling about the fact that we're running out of room? Should I be more careful about what I'm writing? Should we?
No, I'm feeling good. I'm feeling really good about this. I knew that logs and metrics were going to take up the bulk of the board space, because those are really the biggest things that we look at in Kubernetes monitoring. Traces and profiles. We definitely have traces and profiles. Traces and profiles are most interesting to the app developers that wrote that software. So I'm going to talk about them a lot less, because there are traces that are generated within Kubernetes. The API server generates traces, and you can hook up your collector to get those traces and store them somewhere. But the traces are going to be the most interesting to the API server developers, because they're going to want to know, how is the API server behaving? Same thing with profiles. It's going to be about the performance of those components. And so when you're just looking at Kubernetes monitoring as kind of a holistic thing, I'm a platform developer and I'm starting up my cluster and I want to know that things are performing well. I'm not typically going to be looking at API server traces more than I am just looking at the metrics that says the API server says A-OK, so we're going to keep going there. But applications that you are running on Kubernetes, those will be generating traces and profiles. And so we definitely want to be aware that they exist. We want to capture them. The same collector process that we've talked about, the daemon set that's capturing logs, the deployment or stateful set, or however you want to capture the metrics, those ones will be configurable to capture traces and profiles and then send those off to your storage too.
I have a question.
Please.
So it seems like traces can be, well, I have two questions.
Yeah.
First of all, I'm just going to ask them both and you can tell them what order. So one is like, why do you even want API traces? Like you're dismissing them, which is great, but like what is a use case for when you want them? The next one is, in terms of tracing data that comes from applications, I hear of two different ways of getting that. One is by like the sidecar method with like Istio or like a service mesh that's and the other, which is more infrastructure based, and the other is by application developers actually instrumenting their code to be able to create the traces that they want to see.
Yep.
I don't know what the question is, but like, can you maybe speak to which one you're talking about, or maybe both?
Yeah, perfect. Yeah. As far as the API server stuff, the people who are going to find that the most interesting are going to be Kubernetes devs, people who are looking at the health of the Kubernetes itself, like the software of Kubernetes. And so if I'm just a platform operator that's running a cluster, I'm not going to be looking at the traces of the API server or the components as much. But if I'm, part of the Kubernetes project and I'm developing it, I want to make sure that things are running well. I would be looking more at the traces of those internals. As far as the other trace sources, you're absolutely right. The main places where we see trace data being generated, it's app developers who are instrumenting their apps. It's the network process where you see kind of interconnections of apps together. Those things we would capture with our collectors. We would send them up to the storage layer, but they start to look at less about the infrastructure of Kubernetes and more about the app layer of things that are running on Kubernetes. Which is definitely, like I said, I'm not trying to necessarily say it's not important or it's less important than from the Kubernetes monitoring perspective, but it is, they work hand in hand. You can't run apps without the cluster, and you don't really need to run a cluster without the apps. But if I had to draw a line somewhere, that's more on the application observability side of things.
Okay.
It is worth mentioning, and this is a great time for me to say too, that the infrastructure metrics that we gather, so everything that we've got on the board already so far, so the kube state metrics, node exporter, cAdvisor, you want those with your application metrics and your application traces and things like that, because what we'll see, you're looking at your app metrics, you're looking at the traces generated from your application, and you're saying, there's a little bit of a bottleneck here. We always have a problem when we go to the database, or we always have a problem when we're, invoking this thing. The cluster information that we get can tell you, well, the database is running on this node, and this node is having problems. So maybe it's not the database's fault. Maybe it's not the application's fault. Maybe there's some underlying infrastructure issue that we just need to, relocate it to a new place, and that'll be fine. So it's really looking at the combination of application observability and infrastructure observability, where we see we can kind of get the holistic picture of everything.
App observability is an important piece of holistic picture.
Yeah, I like it. So as my ability to see you clearly is getting smaller and smaller, the last pieces that I kind of wanted to just say, obviously we get all of this data, we need to store it someplace. I could go on and on about different technologies, different databases where things are stored. But there's, time series databases where you're going to put the metrics. There's special log databases where you're going to put logs. You'd want to, the collectors that are gathering all of this data is going to stick them somewhere. There are purpose-built databases for each of these data types. And so you're going to want to put them on a specific place. And then once you have all of the data, the last very important piece is I want to be able to see it. I want to be able to make dashboards and understand things, or build some sort of visualization layer where we can understand what's going on there. And obviously with my Grafana shirt, I very much love Grafana, and I think a lot of people know Grafana, the Grafana project, as far as its ability to create dashboards and visualize all of this complex data. And so that's a very important piece. Once you have the data, you need to turn it into something that gives you a visual you can make sense about.
Okay. So as an app operator wanting to implement observability, wanting to monitor my Kubernetes cluster, I'm worried about, I want to be aware of all the common data types, but I'm especially concerned with capturing my logging and metrics. Yep. And so we talked about different ways, and we'll recap here shortly. We talked about ways to capture each. And then our next problem is where to store it. And so, and then there are purpose-built databases for each of these different data types.
Yep.
which do you think there's anything more to say about that? Like, what makes like a logging database good for logs?
Right. That's a really great question. Like I think a lot of people felt similar pain when I told the story about getting like the 2 gigabyte zip file full of text documents. That effectively is a log database. It's a very bad one, but I was able to look through logs, but we've got so many better tools today as far as how do we actually get that log data? Do we extract information from it? And then most importantly, search through it, right? So a modern log database will be able to accept all of this kind of raw text data and then capture it into streams that we can easily search on. So you'll use some sort of query language to say, give me all of the logs that came from this specific application, or give me all of the logs that are from this cluster in this namespace that have the word error in it or something like that. And so a good logging database will be able to find that information, even if it's coming in as just kind of free form text, and then return it to you very quickly. So it does all of the the Command F stuff that I used to do 15 years ago, but it does it much more efficiently than I was able to.
And so it's really optimized for searching or querying logs. And then similarly, I imagine a metrics database is optimized for searching.
That's right. Yep. So, metrics databases will be time series databases. So they're really good at understanding the measurements over time and being able to, you send a query to say, give me all of the CPU metrics for my cluster. And oh, by the way, I want them from 2 weeks ago until 1 week ago. And so it can not only give you the information, but over certain slices of a time frame, give that sort of information.
Time series. That's not a word, but it's good.
It's good. I like it. Yeah.
It's time series. And then visualization is the cherry on top. When you've done everything else well, you can do visualization. And so you did talk about it and you plugged Grafana, which I respect, but will you restate about visualization and why is it? I guess we have some questions that I should answer before we get into visualization, but why is it important is going to be my question. But do you know what pprof is? Why do we use pprof and how is it useful?
Pprof, no, that's a great question. So pprof is a tool that we use to capture profiles, to actually get profiles. When we talk about instrumenting apps, there's certain times where the app developer builds an SDK into your app, and this is what captures the information, and we're going to export it and stuff like that. But there are really interesting and new ways to get this data without having to actually change the application itself, and so that without having to change the source code of the app. eBPF is another one that's building steam. pprof is another one, and so when we're capturing profiles, we can ask the node, hey, I want to get this sort of information, and pprof is one of the methods by which we can do that. And so then it can build this profiles information often without having to change the actual source code of the app, which is great, right? Because it's a lot easier for the app developer. It's easier for us to get the information without having to modify programs.
I'm making room over here. And then Epic Tralala has a shout out for
Mimir. Yeah,
Mimir
is Mimir is one of Grafana's special databases. Grafana Mimir, open source project. Grafana Mimir is actually the metrics database. Grafana Loki is the logs database. They're both open source projects, and so they're easy to deploy onto your cluster if you want to start getting that information there. Yeah. I love it.
I am going to do a Loki episode coming up.
Oh yeah, I'm excited for that.
Yeah, so Nicole. So now we have two spaces far apart from each other, but to talk about visualization.
Yeah.
So what do we
visualization.
need?
Why is it important? All of this data
Yeah.
is useful and it's fun, but all of this data doesn't do anything if we're not able to actually see it and understand why it's there, right?
Mm-hmm.
You know, if the speedometer on my car is not useful unless I can see it. The gas gauge is not really useful unless I can see it. So this data exists and that's great, but we need to be able to see it and ideally see it in a way that helps us understand what's going on immediately. You had asked a question about calculations. You know, are these metrics being calculated at the metric source or the collector source or later on? The calculations that we do are really all about helping humans, helping us actually understand the implications of the data that we see. So an example of, you know, there's a metric data point that is, here's how much space is on my hard disk. Here's another metric would be, here's how much space is left on my hard disk. And I could look at those two numbers and then in my mind, I could do the math, you know, one's greater than the other. I think I'm good. But if you turn that into a gauge or you turn that into a like a line graph and I can see it going down over time, that is a much more rich experience where I can look at that and go like, oh, I understand. No, that's, you know, the slice of the pie that shows remaining is real small and I should be worried about that. Or, you know, it's, you know, disk space or something like that. I see a trend over time and it's steadily going down. I can even use that to predict in the future that's going to go to zero at some point. And so the visualization layer is, you know, obviously a very important part because it helps us actually turn all of this information into something that, you know, people look at and go, I get what's going on. There are pre-made dashboards out there for Kubernetes monitoring that really help with a lot of this. The part of Grafana Labs where I work is all about monitoring Kubernetes clusters, and so we've got tons of resources for that too. So if you want to learn more about that, you know, you can find me and ask me, and I'd be happy to keep going more than an hour and a half on this sort of topic.
And you actually wanted to talk too about a Helm chart that you're working on.
Yeah. So one of the projects that myself and my squad have developed that I'm very, very excited for. There's obviously a lot of the stuff on the board. This seems really complex. And if you're thinking, hey, if I'm developing, you know, I'm deploying my Kubernetes cluster, I want to start getting all of this information, but this seems like a lot to keep track of. The Helm chart that we linked to right there, this is one that I made that really aims at being kind of a one-click deployment to start with all of this stuff. This Helm chart can deploy all of the add-ons that we talked about, so kubestate metrics and node exporter, even OpenCost and Kepler. Those will get deployed onto the cluster. It deploys a collector that's pre-configured to find all of this stuff and then capture all of this stuff and then send it to the databases that you have. And so it really aims at making it super easy to get started. But it's also, it's developed to be very scalable. So this is the same one that I recommend people use if they've got very large clusters or if it's just even a very small hobby cluster. It's the same one that works on both sides.
And it's all open source?
And it's all open source. Yep. Awesome. I love it being open source. I love interacting with the community. We've gotten a lot of great issues and PRs open from people in the community. Yeah, I try to get those looked at and merged real quick. So yeah, please take a look and engage with us there too.
Awesome. So I still have this precious white spot. I guess I could move my head over here.
Yeah.
But I'm going to go ahead, I think, unless you have something in mind that you think would be valuable there. I think I'm going to start the recap and then maybe it'll become clear to us what last bit of information we want to capture in that,
perfect.
One little spot. All right. So to give some context, observability is just about better understanding what's happening in the system. So this helps you fix problems, but it also helps you find problems before they're problems, like fix issues before there are even problems. And also, one thing you said that I really like is it helps us build confidence in what we're doing and what we're deploying. So we talked about the signals, and I was already familiar with logs, metrics, and traces, and you introduced me to a new one. So logging is an event in time. It's usually text-based, and there can be structured logs that might have extra data attached, or unstructured, which are just simply a line of text to represent an event. Or there are metrics, which is measuring events over time. So it has a time, some sort of timestamp, a numerical element, and a label. And what a metric might be measuring is there's so many possible aspects that a metric could be measuring. It's a little overwhelming to me to think about. And then we have traces, which are tracking one event across different locations. And then finally, profiles, which is the new one. So in this one, we're talking trends across locations.
Mm-hmm.
So I thought of it like if logging is each log altogether, a string of logs would represent a trace, then maybe lots of metrics together can represent a big trend. So then we talked about what is monitoring Kubernetes and why do we need to do it?
Right.
So if you can understand your Kubernetes performance, then you can improve your Kubernetes performance. So the goal is optimization. So we said specifically monitoring Kubernetes is helpful for things like bug fixing, right sizing, cost improvement. There's more room. What's a couple other things it's good for?
It's good for, energy. We talked about energy. We talked about even as a companion to the applications too. Helping
Holistic
understand
view.
App performance as well.
Cool. Ravi says there's very little mention of open telemetry in this. Spicy.
I definitely acknowledge that. And it wasn't necessarily an intentional oversight of open telemetry, but what I wanted to do is not necessarily talk too much about individual technologies. Open telemetry is obviously very important in the observability space. A lot of these things are very much applicable and the same within open telemetry. Open telemetry as like an ecosystem for generating and capturing this information. It's hugely important, especially on the traces side of things. But it is also important on all of the logs and metrics inside of things. And I think I mentioned also that OpenTelemetry is picking up profiles as a built-in signal as well. So OpenTelemetry also very much relevant for all of these things. From the collector side of things, OpenTelemetry has the OpenTelemetry collector, which can be the collector that you use to capture the logs and the metrics. And then when we talk about traces and profiles, especially with traces, traces can be pushed often to OpenTelemetry. So rather than metrics, which are often scraped kind of like in a pull model, the traces are often pushed to the collector, like an OpenTelemetry collector. So it was not an intentional slight against OpenTelemetry or an oversight or anything like that. But I wanted to try to capture a lot of this information in a like a software agnostic or a software project agnostic manner.
I love that. And for those who are newer like me, OpenTelemetry is both a standardization and a collector as an implementation. So it could just be a standardization for how like a protocol, the OTLP protocol, the P stands for protocol, just for how these are expressed. And then there's also a collector for how they're collected. So efficiency in Kubernetes, what is that? What does that even mean when we talk about efficiency? So we want to find the balance of avoiding wasting infrastructure resources, but also have enough extra room in our infrastructure resources that if we do get a spike, our system can handle it. So we also want to optimize cost and we want to optimize energy use, which we'll talk more about soon. So we talked about where do we get logs in Kubernetes? So we have our worker and our control plane machines. So there are three types of logs in Kubernetes. We have pod logs, and pod logs are stored in directories on the respective host machine, on the same host machine as the log. Then we have kubelet or node logs, and those are also stored in directories on the host machine, although it's a different directory. Then we have cluster events. Cluster events are accessed via the API server. And I think they're stored in etcd. They're when we wrote probably stored in etcd. Yeah. We're not sure. But they're attached to the, when you like kubectl describe an object, you see pod events there. Yep. And so those are the 3 types of logs that are getting emitted in your Kubernetes cluster. So how do we capture those logs? So the most common way is to install a daemon set that gets all 3 types of logs. So another way is also to add sidecars, and the sidecars are running alongside all of your workload containers, right? All of your applications. So the logs, the sidecar logs will get logs directly from applications, but you don't get node logs in that way. Mm-hmm. And it can have very high overhead if you have a lot of different pods running, but you get flexibility as part of that.
Yeah, and with that flexibility, you get the ability to say only for pods in this namespace do I want to get the, put the sidecar on there. So flexibility in deployment as well.
Mm-hmm. And then, okay, so then we talked about metrics. So there are 3 ways that metrics are built in. Metrics collecting, is that collecting? Are built
or like
into Kubernetes.
Data sources built into the cluster.
Yeah, are being emitted by Kubernetes. Yeah. Generated. Metrics are being generated. That's the word. Are being emitted by Kubernetes. So we have the control plane components, each generate metrics about their state. Each kubelet generates metrics, but that kubelet's going to generate metrics about the kubelet itself, but it's also going to generate metrics about the pods that it's running. Mm-hmm. And then we have a component called cAdvisor, and that is running on every cluster, on every node too. Yep. Yeah, and it's collecting container metrics. So that's where we're getting the granular metrics about like how much resource usage is emitted by a particular container, network traffic, that sort of thing. Uh-huh. So like in this one, we talked about how logs are stored like in directories on the host. For these, each method is storing the metrics information in memory, and then it's waiting for a metrics collector to ask for the metrics, and then it hands off the metrics as soon as it's asked. Mm-hmm. So that collector coming in and asking for metrics is called scraping, and how often it happens is a scrape interval. That's new to me, but it's quite a visceral picture. So that's how the metrics are captured. And then the collector, we didn't talk too much about metrics collectors. But then we talked about what types of metrics are collected, because it sounds like you wanted to talk about this anyway, but I also just asked a question because I was kind of overwhelmed by that possibility of all the different metrics that could be collected. Yeah. So what's common are these 4 pieces of software. One is called a node exporter, which captures all the node health related metrics. So that's GPU, CPU, memory, disk space, and that one gets installed as a daemon set. Then you talked about kube state metrics, or KSM, and that one is going to generate the actual state versus the desired state over time. The metrics related to that. So an example of that is like maybe you have a replica set that's supposed to have 3 replicas, and it does, but one of those replicas keeps crashing and coming back and crashing and coming back. So this KSM, or kube state network metrics, is going to capture something like that. Yep. Then we have open cost, which is capturing the cost of running infrastructure. So it knows the cost of different infrastructures on different cloud providers. And so you can like get a number for what is the exact cost of scaling up this cluster in real time for these compute resources at this moment, which is pretty cool. And then finally, we talked about Kepler, which captures energy use of a workload. So you can maybe determine which processor is more energy efficient for that particular workload. Yeah. And then we talked about traces and profiles. So we talked about logging and metrics rather a lot. And then with traces and profiles, we didn't say a lot about those because they're really more about the application level than the infrastructure level, which we've been focusing on today. So app developers are wanting to know about traces because they really help show app behavior, what an app is actually doing. So the Cube API admits traces, so the app developers are interested in those, but app developers are likely to instrument their applications to generate traces also.
Yeah.
But this app observability part shouldn't be ignored by infrastructure types, by cluster operators, because it is an important piece of getting a holistic view of what's happening in the cluster. If something's going wrong in an application, it might be a problem with the infrastructure.
Right.
And so it's important to know. So then we talked about how the logs are created, how the metrics are created, how we're capturing those. And then what happens once we capture them? We need to store them somewhere. So when you store telemetry data, there are purpose-built databases for each type of data. So we talked about a logging database is optimized for what is it going to take to search logs to find what you need in logs in a reasonable amount of time. And metrics database is time serialized, so it's going to know, you can look up a point in time and see what's happening, for example. And we'll learn more about that as the Enlightning series unfolds and we cover lots of different technologies. And then finally, visualization. I think, to me, visualization is like the chair. It's like you did it. You put in all this work, and visualization is your reward, right?
Yep.
So if you have all this data, you've collected it, you've stored it. Now you can use visualization to see and understand what's happening in your system. So and it's more than just see and understand. You can ask questions about what's happening in the system and get meaningful answers. And this is one question I had during the stream is about metrics, because metrics involve calculation and like, where's that compute happening? Where's the calculating happening? And you said the compute of calculating is probably happening as part of the visualization element. And so queries and calculations and visualization all happens within a dashboard. I guess we didn't use the word dashboard. So I thought of a few things that could go in this space. One is just some examples of metrics. Another thing is something more about dashboards. We wrote visualization, but we didn't write the word dashboards.
Right.
Oh, and the third thing I lost, but that's okay. Yeah, what do you think? Well, first of all, is there anything you'd like to add? Or, open telemetry. We could say a little something about open telemetry. At the
right. Yep.
But how do you feel about the summary? Is there anything that I missed, or anything that in general needs to be said about Kubernetes observability?
I think you captured it beautifully. I think it all sounds great. Yeah. Obviously, with all things, there's always little edge cases that change things a little bit. One thing that came to mind is you mentioned the compute side of things. Sometimes, most of the time, it's in the dashboard, it's in the visualization layer. Sometimes you can deploy things to the storage layer that will automatically do some of that compute stuff. But rarely is it on the collection side, because you want that to be fast, you want that to be efficient. You don't want to overtax the stuff that's on your cluster. But sometimes you can tell the database, hey, when these two metrics come in, do this math and then store that as a third type. So, and then it makes the visualization side faster and easier.
As an outsider who just is recently learning about Kubernetes, like, I knew about the signals, or three of them anyway. Yeah. But what I didn't understand, what I'm like really appreciating as I'm digging into this, is that all three of these signals have to be considered completely separately. They're all generated separately. They're all use different technologies to collect them, different technologies to store them. Yeah. So I'm surprised. I guess I pictured it. I guess, I don't know. I just pictured it more as one big thing instead of three separate things that are woven together.
They're all kind of, I mean, in a way, there are 3 or 4 different ways of looking at, they're there to answer different questions, right? It's logs are looking at like, hey, what happened at this moment? And then metrics are like, tell me about, what happened at this moment too, but in a different way. Like, I don't want to have to actually read through the logs to understand, how successful thing was. I just want to look at a metric. And traces and profiles also similarly. It's about like, what was the path, and then what was the path, but also like, tell me how did it go, more so than tell me what happened, right? But they all do really rely on each other, because if I look at metrics alone, metrics could tell me, what, when people call this website, they're getting error 500s. But then I'm going to go, but now I want to look at the logs and find out why. Or, the speed is really slow. The users are getting a really slow response. I want to look at the profiles to tell me, where's the bottleneck. But then I want to look at the logs and say, like, is it just like poorly engineered, or is there a reason why that thing is slow? And so they all kind of lean on each other to give like a full picture about what's going on there. And oftentimes you can actually do things. This is really interesting. We didn't really talk about this much, but you can do things like take a look at the logs and actually generate metrics from the logs. And so you could say things like, every time there's a very specific kind of failure, we log a log statement that says, super bad failure happened. And so then what you could do is you could make a metric source that counts the number of times you see that. And so it doesn't have to always start as a metric. It could be something that you build from something else. Or a different example is, if you have in your log statement, you've got a special key, you can track that key as it shows up in different logs across different services, and you can even make profile or traces out of that. And then if you have timing data, you can maybe even make profiles out of all of that information. So there's ways that they do kind of lean on each other. There's ways that they depend on each other. There's ways that they can even build from each other too. So it's easy to kind of look at them as separate things, and we store them as separate things, but they really are 4 views on the same system. It's not really useful to just look at one of them alone.
These signals come together as part of a dashboard or as part of visualization. Is that true?
Yeah, in a dashboard, I'd say. Dashboard is just kind of, the shorthand for, a single visualization. And it fits well with the car analogy that I've been working on the whole time. So the literal dashboard.
Oh, yes. Drive it home. Awesome. Okay, cool. Yay. Well, I think that's a wrap, friends. We did it.
I love it. That's great.
Yeah, this has been really wonderful. Thank you, Pete, and thank you, everyone. I've got just really great questions and lots of new friends today, so I appreciate that. I'm going to put the music back on, and we're going to dance a little bit.
I love it. Yeah.
Yeah. There it is. Thanks, all friends in chat, and all your great questions. Thanks to everyone who watched the recording later. I appreciate you. Bye.